so that you can see. So the recording is starting now. So I'm very happy today to introduce a joint lecture by Sandhya Sundaresan and Thomas McFadden. And I will introduce each of them separately. It's kind of would be difficult to introduce them both at exactly the same time. So I will use alphabetical order of the last names, which will mean that I'll first introduce Tom McFadden. Tom got his PhD in 2004 from the University of Pennsylvania, working on case. He has, since then he's been working in Stuttgart, Tromsø, and at the moment is now at the research center at the SAS in Berlin. And he works on theoretical and comparative syntax, on morphology, syntax morphology interface. Primary topics are case agreement, clause structure. I could go on and on and on. Many of you know he focuses on Germanic languages and other languages, comparative work. He's also done some electronic corpus work, historical syntax, so a wide range of interests. Sandhya Sundaresan got her PhD in 2013, jointly from the universities of Tromsø and Stuttgart. And she has worked as an assistant professor at the University of Leipzig and is currently at the University in Göttingen in a research project dealing with syntactic locality, which is one of the topics of today's talk, together with Tom McFadden, Robert Truswell, and Hedy Zestra, who's here with us today. Her particular research interests are theoretical syntax, syntax semantics interface, microvariation, also the syntactic underpinnings of reference, various phenomena such as anaphora and logophores, control, indexical shift, and various others. She works primarily on Tamil, the Dravidian language, and Tamil dialects. And they also do quite a bit of work together. And so we'll have a joint talk from them today. But before that, the one thing that I can say jointly about the two of them is that we are absolutely delighted that they're joining the linguistics department at Stony Brook starting next academic year, both of them. And I'm so delighted, you guys, you have no idea. It's just fantastic. And that's, you know, to the people out there who are not Stony Brook, it still might be interesting to know that it is possible to do these kinds of things. And we're just absolutely delighted, and we can't wait until you get here. So hurry up, we're waiting for you. And the title of the talk is a little bit lengthy, but I will try to say it. Towards a path-based theory of syntactic locality and selective opacity. Please unmute your microphones for a second so we can actually clap to welcome Thomas McFadden and Sandhya Sundaresan. Take it away.
Thank you so much. So I'm just going to share the slides here. So hopefully everybody can see that. Yes? Okay, great. So thanks very much to John for inviting us to give this talk. It's coming at a very fortuitous time because the project that John mentioned is just started, and it's again joint work with Hedy Zestra and Rob Truswell, and we have a project that's hiring a couple postdocs, and this is a very nice opportunity for us to showcase the work that we're doing. So thanks very much for being here and for listening, and any hard questions you have, you should direct them to Hedy because he's shown up. So that's just for a heads up. Okay, so I'm going to start with a very sort of intuitive introduction, and then we'll progress towards the technical part. A fundamental tenet is that syntactic dependencies in natural languages are constrained by locality. Now, this is something everybody knows about, but just to be thorough, so in English, subject-verb agreement has to be clause internal. So Susan said that they is loud is bad because Susan is the matrix subject and cannot trigger agreement on the embedded verb, right? And you can also see this in binding, classic Chomsky 1981 binding condition A. Susan said that they hated herself is bad because, again, you have a dependency across two clauses. You get this with certain types of movement called a movement involving arguments. So Susan seemed that is happy is bad because Susan has moved out of a finite clause. Incidentally, both 2 and 3 are grammatical in other languages. So this is specific for English and languages like English. Just to show you that locality is sort of at play in all of these cases. But even in English, if you look at different types of structures, and once you broaden your focus from English to different types of languages, we see that the notion of syntactic locality, this tenet that has been assumed to be so basic to syntactic dependencies, is actually more complex and nuanced. So I'll use the terms locality and opacity interchangeably, right? So syntactic locality or opacity is selective across different types of parameters, across domains, by which I mean structural units, across types of syntactic operations, so whether it's movement or agreement or something else, and also across languages. And what we're going to do today is actually focus on this kind of selective opacity across domains and operations in one particular area, namely that of the distinction between complements and adjuncts. So when I say that selective opacity can be relativized to syntactic domains or operations, what I mean is one and the same syntactic dependency is possible out of one type of structure, but is not possible out of another type of structure. Okay, so this is where we'll actually talk about adjuncts versus complements. Selective opacity across operations is where one and the same chunk of structure allows one type of operation but blocks another type of operation. And we'll see that adjuncts actually show both of these. So the selective opacity across domains, a very famous sort of restriction in syntax that was noticed early in the 80s is the so-called condition on extraction domains, or the CED. And what it basically says is that a particular type of syntactic dependency, in particular syntactic movement, cannot cross a phrase XP unless that phrase is a complement. Okay, so the sort of classic kind of difference that you get is the sentence in 4 versus that in 5. So you can say, who were you surprised that you saw? Because that you saw is actually a complement of the matrix verb, and you can extract the who out of that. But you cannot say, who were you surprised after you saw? Right? Because after is a temporal adjunct, and you cannot move the WH element out of that. Now, some people might not like 4 very much, because a lot of people don't like movement out of factive complements, but that's okay, right? So for enough people, there is a discrepancy between 4 and 5. So that's the kind of selective opacity across domains involving adjuncts and complements. Now, prior accounts of the CED have involved giving adjuncts some sort of special primitive status. So you say, well, you can't move out of an adjunct because an adjunct is special in some way, right? So you need a special kind of movement out of adjuncts, like a sideward movement. Or adjuncts are late merged. They're merged later in the derivation. Or adjuncts have a special phasal status. Adjuncts are phasal in a way that complements are not. So all of these sort of presuppose that you need special rules to explain why something is movement is blocked out of adjuncts but is possible out of complements. Now, first of all, this is a little bit ad hoc, because whenever you come up with a new rule or a new condition, that's less preferable than if you can do without that, all else being equal. And there's also an empirical problem with that, which is that adjuncts actually don't block all syntactic dependencies. Okay, so first, the CED itself is not absolute. So movement out of some adjuncts is actually possible in apparent violation of the CED. So let's look at 6 versus 7. What did Maria work while whistling is bad, right? But if I were to say, what did Maria drive Jill crazy whistling? That's surprisingly okay. And notice that in both these cases, the structure that's in brackets, the whistling, is actually an adjunct, right? So in one case, in 7, you can move what out of that, but in 6, you cannot. And so Rob Truswell, who's also involved in this project, so he looked at cases like these in great detail, and he argued that movement out of an adjunct is possible just in case the host and the adjunct together describe a complex event. and he called this the single event condition. So what happens in 7 is that Maria's whistling drove Jill crazy. So you have a resultative predicate where there is, as a result of Maria whistling, Jill was driven crazy. Whereas in 6, you don't have that same kind of connection between the two events. So that shows that the CED is more complex. The second kind of selective opacity, the second problem is with the CED is that adjuncts are actually transparent to some operations, but not others. So what we'll see is that one and the same adjunct can block one type of syntactic operation, movement, which we saw with the CED, but it can be transparent to another type of syntactic operation. So one sort of case that we are particularly interested in is so-called adjunct control, which has been independently shown to be syntactic. So obligatory control is allowed into both complements and adjuncts. So I could say, Vivek enjoyed reading the book, where reading the book is a complement. And so you have a control dependency between the embedded subject, the so-called big pro, and Vivek. And in 9, you have Vivek traveled while reading the book, or Vivek traveled reading the book. And this dependency is also possible. So on the one hand, you have movement that's blocked, but on the other hand, you have control, which is allowed. And just to drive the point home, one and the same adjunct clause, while transparent for obligatory control, still blocks WH movement. So Vivek traveled while reading the book is fine, but what did Vivek travel while reading is bad. Okay, so that just sort of gives a nice contrast for one and the same clausal adjunct. So the research question that we will sort of try to try to get a handle on today is the following. Why do adjuncts typically block syntactic dependencies like movement that complements allow? So what is this difference between adjuncts and complements? And can we do that without resorting to ad hoc rules that accord adjunct a special status? How do we account for cases where adjunct blocking movement is obviated, for example, the single event condition? And why does one and the same adjunct block one type of syntactic dependency, like movement, while allowing another type of dependency, like adjunct control? So that's our agenda, and whoops, sorry. Hold on. Okay, so looking at phi agreement across adjuncts provides us with an important clue to solving this cluster of puzzles. So the first thing to notice is that in the phenomenon of so-called long distance agreement, phi agreement out of an adjunct is blocked, but phi agreement out of a complement is allowed. So this looks a lot like the CED, right? So just like movement out of an adjunct is blocked, movement out of a complement is allowed, phi agreement seems to mirror these effects. So long distance agreement is exemplified in a language like Hindi. So in Hindi, a matrix verb can show long distance or non-local agreement with the object of an embedded clause. But crucially, this long distance agreement is only possible if the embedded clause is a complement, as in 12, and not if it is an adjunct, as in 13. So in 12, you have Vivek wanted to read the book. And so what you have is you get feminine agreement on want in the matrix clause, which agrees with the book in the embedded clause. But you don't have an equivalent of long distance agreement in a sentence like 13, where to buy the book is actually an adjunct. Vivek worked to buy the book. Now, I have a long slide that basically shows that more carefully with examples of adjunct long distance agreement in Hindi failing. We tried to come up with, this is data from Rajesh Bhatt, and we tried to come up with sentences that are as close to the complement long distance agreement as possible in Hindi, so that's also restructured. It's also a non-finite clause and whatever else. And this is basically just to show you that even if you go to all that trouble, you cannot get long distance agreement into an adjunct clause in Hindi. So there is that thing, right? So you cannot have long distance phi agreement. You can't have a verb that's in a host trying to agree with something inside an adjunct clause. That's not possible. But interestingly, the reverse is possible, right? So adjuncts may themselves show phi agreement with something in their hosts. And this is a very pedestrian phenomenon. So in many languages, an adjective or modifier of a noun can actually show phi agreement with the nominal. And this is shown for Latin, right? So you have all of these adjectives that show, so if you have tabula bona, right, you have good, which shows feminine agreement with table, right? I mean, it's not a great example. Or you have like good field, where you have masculine agreement with the noun and so on. So what does this show us? If you take these patterns of phi agreement together, you get a really interesting discrepancy. Phi agreement is blocked into an adjunct. In other words, when an element in the host shows agreement with an element inside the adjunct, that's what we saw with long distance agreement. But interestingly, phi agreement is allowed out of an adjunct. So when the adjunct or something in the adjunct shows agreement with an element in the host. And that's what we saw with adjective noun agreement. And we think this is not trivial, right? And if we generalize this intuition across other operations, we can immediately get a handle on why control is possible out of an adjunct, but movement out of an adjunct is typically not possible, because they fit into the same pattern. So adjunct obligatory control is a syntactic dependency out of an adjunct, right? And this is allowed. Why is it a syntactic dependency out of an adjunct? In a sentence like, Vivek walked, or what was the example? Vivek went to the store to buy books. In that case, the big pro subject inside the adjunct clause is syntactically dependent on an argument in the main clause, right? And that's allowed. But the CED is actually a dependency into an adjunct and is blocked. So if you have WH movement out of an adjunct, the proby element, the element that says move to me, right? That element in the landing site is dependent on an element in the adjunct. That's the element that's actually moved. And so that reverse dependency seems to be blocked, right? So to summarize, syntactic dependencies out of an adjunct are okay. Syntactic dependencies into an adjunct are not okay. And that's essentially the core insight that we'll build on. We'll propose that these selective opacity effects involving adjuncts and complements involve this systematic directionality asymmetry. So complements, for some reason, don't seem to care about this. Complements say, you can have a syntactic dependency out of me, or you can have a syntactic dependency into me. But adjuncts really care about whether the dependency is out of them or into them. In other words, they're selectively opaque with respect to the direction of the dependency. So an adjunct allows a syntactic dependency out of it, but it blocks syntactic dependencies into it. And we can formalize this. We can phrase this intuition a bit more formally. So working in the minimalist framework, the general idea is that all syntactic dependencies are driven by this abstract operation called agree. And this is a local syntactic dependency between a probe. This is an element that says, I am dependent on some other element, and a goal is the element that says, I can satisfy the needs of the probe. So within this paradigm, we can rephrase our intuition in the following way. Complements allow probing both into them and out of them. Adjuncts allow probing out of them, but they block probing into them. Okay, so that's the main insight. Now, why should this be the case? I mean, this is nice, it's interesting, but we need a way for this to fall out of natural and independent differences between adjuncts and complements. Otherwise, it's just ad hoc. So what we need now is a theory of how adjuncts and complements are actually different from one another, that is independent of what we've said so far. And we also need a theory of agree that directly acts on this first point to deliver the differences between adjuncts and complements that we've just seen. So this is what we're going to turn to next. And this is the more technical part of the talk. So an important distinction that we make, and this is a very fundamental distinction, is between structure building and structure enrichment. Structure building is the act of putting together smaller syntactic objects to make larger syntactic objects. In minimalist terms, this is obtained via the process of what's called merge, right? And structure enrichment involves the transfer of information between nodes of a between parts of a syntactic structure that have already been built, right? And we include phenomena like agreement or case assignment in this. Now, this is building on work by Björkman and Zijlstra and more recent work by Hedde. We're gonna formalize this distinction in terms of two operations. So we're gonna talk about checking. Checking will underlie structure building, and it's the part of the conditions on merge, and so it only operates under sisterhood. Valuation underlies structure enrichment. So valuation presupposes that the structure has already been built, and it can only operate on the basis of structure building. Another way to say this is that valuation is parasitic on checking. And this also means that valuation is less local in the sense it doesn't have to happen under sisterhood. Okay. So what we say here is basically going to superimpose the toolbox and the vocabulary of minimalism with intuitions from categorical grammar. So, and this has to do with how structures are built. We're going to say that the label of a syntactic node is just the set of features it bears. And by the way, if it's all general, we'll look through trees, so it's not a problem. We're going to have categorical features, and these come in matching pairs of F, which is inherent, and UF, where the U diacritic means that it's unvalued. It's looking for something. It's looking for F. Each instance of merge must involve two nodes, one containing F and the other a matching UF. This is basically just C selection, right? The resulting node, once you merge the node carrying F with that carrying UF, and this is the difference, right, from standard assumptions in minimalism, is the set union of the features of the merged nodes. So everything other than F and UF will percolate up. Okay. So by default, everything projects from both sides. So this sort of turns the idea of what's ahead and what's not ahead, right? I mean, everything projects from both sides. Checking is not deletion or anything special. It's just the failure of the features that drove the merge to project further. Okay, so let's look at a very nice example, simple example, like eat pierogi, right? This is classically would be a verb phrase. So you have a transitive verb, which is eat. And eat comes with the following categorical features. It says, I'm a verb, so it's got a V feature. And it says, I'm a transitive verb. So that means I'm looking for a nouny thing to merge with. So it's got a V and it's got a UD, right? Now, pierogi has a D, and so you put those together. By the way, the colors are just for emphasis. And this is the crucial thing. The UD and the D check each other. So what percolates is the V. So far, this looks indistinguishable from classic minimalism, but you have to imagine there could be a case where the D also has an additional feature, and in that case, since it's not checked, that would also percolate up. Okay. So, right. So checking as part of merge always happens under sisterhood. It's super local, as seems right for basic C selection, right? It has to happen with two elements that merge with each other. But checking is not enough. We also need valuation. And valuation is for structure enrichment. It allows action at a distance. So why do we need that? Because dependencies like phi agreement and movement do not seem to be restricted to sisterhood. You might even have anti-locality effects. And especially given things like long distance agreement, it's clear that that doesn't happen under sisterhood. So you need a way to talk about dependencies between two elements that are further away from each other. These dependencies also don't involve requirements that an element of the right type has to be added to the structure, requiring an object or anything like that, right? That's not the kind of dependency that is. And furthermore, there seems to be a fundamental distinction between structure building and structure enrichment, which is that structure enrichment seems to tolerate failure in a way that structure building does not, right? So this is the sort of Preminger idea that agreement can fail. Right. So if two things cannot agree with each other, it doesn't necessarily lead to a crash. You just get a default exponent added in. So the idea we're going to propose here is that valuation can only apply between nodes that are already in a checking relation. This builds on the idea that structure enrichment is parasitic on structure building. And this is where the path-based in our title comes in. We're going to say valuation has to follow selectional paths that are defined by checking relations. And we're going to exploit this proposal to give us the distinction between adjuncts and complements. So I think I turn this over to Tom now, right, Tom? So let me stop sharing and then Tom can share his.
Okay, so hopefully you can see.
Yeah.
You guys can see my, okay, good. Then I'll make it full screen. Okay, so the idea here is that this model that Sandhya has introduced, it allows us to articulate a fundamental difference between adjuncts and complements in a particular way. And there's one of the classic ways to think about the distinction is that is in terms of selection. So a complement is selected by its host, whereas an adjunct is not selected. In fact, it's not selected by anything. And that so far, that's quite standard, quite generally thought. The thing that we're going to add on here is a bit of a tweak of this that some people have suggested before, but is less standard, which is that we're going to say that adjuncts select their hosts. Right, so the most common view is that there's just no selection involved with adjuncts. They have this own, they float off and do their own weird thing. We're going to say, no, actually adjuncts select their hosts rather than being selected by them. And so the fact that an adjunct is not selected by its host seems like a pretty obvious point, given that adjuncts, so that hosts are more or less oblivious and indifferent to whether or not an adjunct is there, right? So as far as the syntactic needs of a noun are concerned, for example, it really doesn't care whether it's got particular adjectives modifying it and so forth, right? The adjunct, of course, does care about its host. An adjunct actually does need to have a host, and often a host of a particular kind, a host of a particular category, right? Just sort of the basic observation that in a language like English, there's a distinction between adjectives and adverbs, and to a large extent, that distinction has to do with the category of the host that they attach to. Adjectives attached to nouns or noun phrases, and adverbs attached to other things like verb phrases or adjectives and so forth. So the way that we can capture this in the current system is to say that an adjunct actually selects its host. And as I suggested, this idea is out there in other places, and it seems to be fairly standard in categorical grammar, for example, that modifiers and adjuncts select the things that they modify. So that means that an adverb like quickly is going to come with a category feature that indicates the category of thing that it modifies, that it adjoins to. So quickly, as an adverb, as an adverb that attaches to verbs, has a UV feature that will select the V feature on a verb like run. Quickly also has an independent V feature of its own. And so the sort of defining aspect, the defining categorical thing about adjuncts is that they have this matching FUF pair, right? They always have one categorical feature that selects and another categorical feature that projects the exact same category, right? To give this idea that they select a host and then they give you back the same category as the host was. And so when quickly selects and merges with run, you project up a V from quickly, actually. The resulting thing, again, is another type of verby thing, right? But it's now got the added adjunct on it. Okay, so now with complements, the selectional pathway involved is reversed directionally. So the host selects the complement, not vice versa. That's sort of the standard and well-known idea about how complements work. Complements are defined as things that are selected by another head. So I've been saying selection, and it was sort of suggested already by what was on the previous slides. The way that we're going to implement selection in formal terms is in terms of the checking operation that Sandhya already introduced, so that this dependency between two features UF and F. Valuation, on the other hand, is distinct from checking, right? And it enriches an already built structure by copying feature values from one place to another. But the thing that's going to do the work for us is that valuation of one feature by another feature is still, it can't just do it willy-nilly. It is dependent on prior checking relationships. So valuation is distinct from checking, but it is dependent on it. And the details of how we're going to do this, for those of you who are familiar with the Bjorkman and Zelstra paper, it has some related ideas, and we're going to depart from that a bit in a couple of ways about how we're going to relate. They also have a dependency between valuation and checking. We're going to depart from it in a couple of ways. First of all, we're going to add a recursive step. So in their formulation, in order for two things to be an evaluation relation, those two heads have to be directly in a checking relation. We're going to add a recursive step in between that says that two nodes can be visible for valuation as long as there is checking that connects them. Even if they don't check each other, there can be like a three-stage checking thing. A checks B, B checks C. Now A and C can see each other for valuation. That's the one thing. The other thing is we're going to add a restriction which says that valuation can only follow checking in one direction, right? So checking is asymmetric, and the valuation that can follow checking is also asymmetric. And all of that, if we put it together in the right way, is going to give us the asymmetries that we saw between complements and adjuncts, and these directionality effects for the selective opacity and adjuncts. So these trees here give you sort of a quick toy view of how this is going to work. So on the left, we have both of these are adjunct structures, and we're going to see if you try to value into and value out of an adjunct, how the one works and the other one doesn't. So starting on the left, we've got here, this down here is an adjunct, right? And it's got these two features. It's got a UC and a C. That's the defining thing for an adjunct, that it's got matching, it's on itself, it has sort of a matching dependent and independent pair of features. So this UC feature is going to select something else that has an independent C feature. So this adjunct selects the host that it attaches to, right? And now what is allowed then is valuation that kind of goes back in the opposite direction. So if there's something inside of the adjunct that has an unvalued feature, right? It's allowed to follow that selection path to look for a matching valued feature to get its value. So probing for a value can go in the same direction as probing for selection, and then the valuation goes back in the opposite direction, and that's okay. Over here, we see the opposite possibility. Again, we have an adjunct. The only difference in the structure here is that we've got a valued feature inside the adjunct and a matching unvalued feature outside the adjunct. So what this structure is going to try to do is have this B head probe down here to try to get a value out of the adjunct. Now, again, the adjunct selects its host, and now we try to do probing. This wants to look inside, but notice that this is probing for selection goes this way. Probing for valuation goes this way. That's a mismatch. That's not allowed. And so the valuation from the adjunct into the host clause is not allowed. That's the basic abstract idea that we're going to carry through for everything. Okay. So see how I'm doing for time. So here's the formalization. I'm not going to spend much time on this. I'm going to put it up and go through it very quickly. Feel free to ask about it later. It'll be more useful to actually work through the trees, but just this is sort of the baseline. The definition of valuation is a feature y unvalued on a probe P can be valued by a matching y with a value on a goal G if and only if P and G are sisters, right? So if two things are if you've got two heads that are sisters, they can value between them. That's fine. Or if there's a feature X on G which checks a feature UX on P, so if there is, that means that the the head that's got a valued feature, right? If it also is has an independent feature that got probed, so that if one head probes the other for selection, it can also probe the other for valuation. That's basically what that's saying. This is the direct version, and 3 is the recursive step. So if you have a sequence of heads, H1, 2, etc., that are in a chain of selection relationships, a chain of checking relationships, you can also have a valuation between things at the end of that, at the two ends of that chain, right? That goes in the correct direction. So, and again, the way to think about this is that probing for valuation has to go in the same direction as probing for checking. The valuation, the actual copying of the feature, goes in the opposite direction. Okay, so this is in sort of simpler terms. Given that checking equals selection, if P selects G, then a feature on P can be valued by a feature on G. And if A selects B and B selects C, then a feature on A can be valued by a feature on C, right? So that's the indirect, that's the chained version, right? And since that second part is recursive, we can use it to define arbitrarily long chains of selection, which in turn create these paths for valuation. Right, this is the way that you're going to be able to get sort of successive cyclic kinds of effects and long distance agreement types of effects, where there's clearly no direct selectional relationship between the things that are participating in the valuation relationship. But it's crucial here that selection only licenses valuation in one direction, right? So if P selects G, that a feature on P can be valued by a feature on G, but not the other way around. That doesn't mean that a feature on G can be valued by a feature on P. It's not ruled out, right? In order for that to be possible, what you need is mutual selection. If you've got two heads, each of which bears a feature that is matched by a dependent feature that's matched by an independent feature on the other, then it's possible for valuation to go both directions. Ultimately, we think that's the sort of thing that's going to underlie the sort of bidirectionality of dependencies and complements that Sandhya mentioned. But we're not going to go into detail on that in this talk for space reasons or time reasons. Okay, so now in the time that's left, I'm going to walk through derivations for some key examples. And in theory, we would do 4 here, but the last one is just way too complicated, so we're going to skip it. We'll just do these first 3. We're going to do long distance agreement, where something in a complement clause values features on something in the matrix clause. That's Hindi style successful long distance agreement. And then we'll do the same thing, but with an adjunct clause, which doesn't work. We're going to show why that doesn't work. And then the last thing is OC into an adjunct clause, where the features of something in an adjunct are valued by something in the host, which is successful and which is one of the things that's tricky for other stories to account for. Okay, so this is a structure for long distance agreement where you've got valuation from a complement clause into a matrix clause. And there's a lot of features floating around here, and it's a little bit hard to follow it, but so I'm going to try to go through it step by step and use colors to hopefully make this as easy to follow as possible. So the overall structure, what we're trying to build here is something like Vivek wants to read the book, where eventually want is going to agree with the book, right? The matrix verb is going to agree with the embedded object. And so starting at the bottom, right, we have a transitive verb read, which has an independent V feature and a dependent D feature. So that's a verb looking for a nouny thing. The book has a D feature because it's a nouny thing, and it's got 5 features, third, feminine, singular. Okay, so we get these features match. So read selects the book, they merge, and the V feature from read projects up. So now the next thing that comes in is a T head. T has a T feature and a UV feature.
Tom, just real quick, can you clarify that the 5 features don't project up because they're not checking features? Just real quick.
Yes, yes. Right. So notice that the V here projects up, but the 5 features from here did not project up. This is a point of detail that we're, for the time being, we're assuming that features that have values on them don't actually just project up. You can kind of do it either way, but there are complications, and it's certainly simpler for the moment to assume that they don't. Feel free to ask us about that in the question period. The reason why you might think they would project up is if you remember from what Sandhya said all the way at the beginning, when two things merge, stuff projects from both sides, right? Everything projects up except for the features that were involved in the selection. So that the UD and the D don't project because they were involved in the selection. So you might have expected the 5 features to project up. And for the moment, we're just assuming that that doesn't happen because it makes things a bit simpler. Okay. So then we have the T head, which has a T feature and a UV feature. So it's a T that's looking for a verby thing. So it selects this verbal object that we've built, right? Those match. That means they will not project up, but the T projects up to the next level. So the result is a TP of sorts. And now we have the matrix verb want, which is a verb that's looking for a TP, and it's also looking for a DP, right? So this is a verb that selects a subject and a clausal complement. So it merges with the TP. So these match. That means that they don't project. What projects up is V and UD. So the result is a verbal thing that's still looking for a D. So it's a VP that's missing its subject argument. Vivek has that D feature. So those match. And what's left over is just this V, which projects up another level. And then we have the matrix T. The matrix T is a T feature because it's a T. It has a UV feature because like any T head, it's looking to combine with a verb phrase layer. And it also has an unvalued 5 feature. So it merges with this VP. Those features match. All that projects up is the T. And now we get to try to deal with the valuation situation. So we've finished structure building, and now it's time for structure enrichment. And what's going to happen? Well, this is looking for something with valued 5 features, and there's valued 5 features down here. And the question is, can this establish a dependency with this for valuation? In other words, can this follow a chain of selection relationships in the right direction that will get it down there? And okay. And so here's how that works. The arrows are showing the selection relationships. So basically, read selected the book. Embedded T selected read the book. Matrix want selected the embedded basically to read the book, right? And the matrix T selected want to read the book. So we've got a chain of selectional relationships. Now, since the dependency for valuation is kind of a transitivity thing, right? There's a transitivity that holds for how you establish a path for evaluation. So even though there's no direct checking relationship between the matrix T and the embedded object, the book, there's a mediated one that goes through the matrix verb, embedded T, and the embedded verb, which you can sort of summarize like this. Okay, you bring that all together, and that means there is a relationship for checking that valuation can now follow. The probing for checking went this way, so the probing for valuation can also go this way. We find a matching 5 feature and copy it up, and voila, we have long distance agreement. One thing that I'll mention right now, in case this is obvious, even though there's a lot of features here, this is massively simplified. Notice that we don't have any little v's or anything like that. But hopefully you can see from the way that this works that adding in extra functional heads in between, as long as they participate in the same kinds of selectional relationships, it doesn't make any principal difference, right? This just makes it a little bit easier to fit the tree on a slide. Okay, so now, what if we tried to do the same thing where the embedded non-finite clause is an adjunct instead of a complement? So here's the structure. This is something like Vivek worked to buy the book. And as Sandhya mentioned, this isn't possible in Hindi. The agreement here isn't possible. And more than that, as far as we've been able to tell, nothing like this shows up in any language that we're aware of. We're not aware of any kind of long distance agreement where the 5 features of an argument inside an adjunct are reflected on the verb in its host clause. Okay. And how does our account deliver that fact? Okay, so building up the structure is fairly similar until we get to the adjunct point. So by the book, by selects the book in the same way. To is the head for the infinitive. This selects the VP. Now, this is kind of a special fun head here. The details of how you do this, there's a couple of different ways you can do it, but all of them will amount to, for our story to work, you need to have a head that's going to take an existing structure and basically turn it into an adjunct. So this particular adjunct infinitive head, right? It's a kind of little v, let's say, right? Which is looking for a VP. So it's going to select the by the book verb phrase. And then it's also got a u little v. So after it gets this verb phrase, what it's going to give us back is something that adjoins two little VPs. So this turns this infinitival clause into an infinitival clause that wants to adjoin to a little VP, right? Because it's got the matching u little v, okay? Now, that is going to select the matrix little VP, which we've simplified here. The internal structure of the matrix verb phrase doesn't matter. Ultimately, you put together Vivek and worked however you like, and you're going to get a little VP. So this selection here, these features match. And so the adjunct clause selects its host, and it projects up a little v. And now that little v can be selected by the matrix T head in the same way as happened in the complement clause. This matrix T head, again, has an unvalued 5 feature, and it's going to try to agree with this. But now here's the problem. Can we get there? Is there a chain of checking relationships that will get us there? No, there isn't. So again, by still selects the book. That's fine. To selects by the book. That step's fine. But the step to get us from anything up here is not going to work because matrix T selects matrix little v, but matrix little v does not select the embedded clause. And matrix T also does not select the embedded clause. There's no way to get from anything in the host clause via selection or via checking into the adjunct clause. So there is no path here for valuation, and so the agreement is going to fail. Okay, so this is why you cannot get long distance agreement with something inside of an adjunct clause. So why is it possible to get obligatory control into an adjunct clause? Well, that's because the dependency, the valuation dependency, goes in the opposite direction. Now this is even more complicated features wise, so bear with me. This is, we're setting up a sentence, Vivek traveled reading the book or traveled while reading the book. So reading the book, we simplify, okay, we call that, reading the book is a little VP that hasn't merged with its subject yet. So it's a little VUD. Now big pro is a D, it's a noun phrase, a DP. And then it's got some extra features that are going to do all of the fancy work for us. So this one here may look sort of mysterious, but it's a pretty straightforward thing that we don't know what to call it, but it's a feature that's going to ultimately be what establishes the control relationship. So it basically says, I'm going to need to get a value from some other element that also has the right kind of feature. And once I get that value from that element, that's going to be what determines my reference. My reference will be basically equal to whatever I get that value from. Now, we need something else on here in order to get the checking relationships that we want. We need here a dependent feature on this, because pro is going to have to come with its own requirement that says, you know what, I need to be in a dependency. I need to be in a type of clause that is a control clause, a clause that is looking for reference from outside, that is looking to get together with a higher clause that will be able to supply me with an antecedent. So here this is where you first see this business of stuff projecting up from both sides doing important work for us, because reading the book is going to select pro. So these two will match, right? But now the little v is left over, but also what's left over is the UCL on pro. Okay, so both of those things are going to project up. We're going to get features coming up from both sides. So the resulting, what that tells us is the resulting thing is a little VP that came from this side, but it's also a little VP that's got a gap in it. It's got a pro. You could think of this as a little bit like a slash feature from HPSG and so forth. This is a control little VP, a little VP that is looking for to find an antecedent so that it can get a reference for its pro subject. Now, this little VP gets selected by the embedded T, right, which has a matching UV feature. What projects up? The T and the UCL again. So again, we've got a TP, but this is a control TP that's looking to be, you can interpret this UCL as I need to be controlled. I need to get together with something that can provide me with an antecedent for my gap. Okay. Then up here, we need another one of these fun heads that takes a clausal structure and turns it into an adjunct that can be adjoined to something of the right type. So it's got a UT feature. That's what's going to select this whole thing. But it's also got a matching UVV, right? Which is the thing that's going to make this into a thing that can adjoin two little VPs. But it's also got an independent CL feature. This is the thing that says, okay, I have created for you the right environment to have a pro. Okay. I am the kind of, you could think of this as a C head of sorts that creates a control infinitive that is ready to be adjoined to a higher clause. Right. So what happens here is that you get, let me do this again, you get sort of mutual selection, right? So this selects this, and this selects this. And so you get double checking at this matching point, at this merge point. And what projects up is just the leftover stuff that turns this into an adjunct on little VPs. Now we've got up here the host clause, the little VP of the host clause, Vivek traveled. And what matters here is that it's a little v that we've gotten out of combining together a little VP plus its subject. Notice that Vivek here has a valued F feature, which you could, maybe this is 5 features, maybe this is a referential feature, maybe it's an ID feature. It's whatever feature, whatever kind of feature is involved in referential dependencies, so in control and maybe also in things like an AFRA, right? So this adjunct clause selects its host.
Hey, Tom,
And now
we have a couple minutes, FYI.
Okay. All right. Thanks. All right. So now, I don't think we can see the arrows. Okay. So what matters now is we've got a selectional relationship, a checking relationship from pro to this C head, because the UCL here gets checked by the CL here. We have a checking relationship from this C head to the host verb, right? Traveled. The UV here checks that, it checks off on that little V there. And then there's a checking relationship from traveled to Vivek, because this UD here gets checked off on Vivek. So we have a checking path from Big Pro to Vivek, and that means that we can go back, we can have a valuation path the same way. The F here can probe Vivek for a value, and so that gives us the relationship, the syntactic dependency that gives us co-reference, that gives us control. I think since we're out of time, maybe I'll just, do you think I should just stop there, Sandhya? You're muted.
Just mention very quickly what happens with the movement, because that's kind of what we started with.
Oh, right. Okay. Yeah. So why can't you move out of adjuncts? If you assume that movement is triggered by a feature that, so movement is a kind of merge, so it has to be triggered by one of these U features. And so the idea is that that U feature will be on the landing site where the movement is supposed to go to. And so a movement in a complement structure works just fine because there's if this is the C head that selected a TP, that T has selected a little VP, and that little V has selected the subject, and so selected its argument, and so on and so forth. And so there is a mediated checking relationship. So this can probe downwards. So the idea that we haven't put in here exactly, but the idea is that that movement involves these two subparts. The merge part is fine. That's just merge. But in order to merge, you have to you have to do the search for an appropriate thing to merge with. And our suggestion is that search for an appropriate thing to merge with follows the same kind of locality dependency as probing for valuation. So it has to follow checking in the right direction. So that works. You can follow checking here. And so you can look down this way to find an appropriate thing to move. But in an adjunct, you have the same problem as with valuation. If you have a matrix C that's looking for a WH element, it can't probe into the adjunct to find a thing to move up to the landing site because there's no selectional relationship. There's no checking relationship at this crucial point. It can find something in the host, but it can't go past that into the adjunct. We have some stuff here about how to deal with the cases like what did Maria drive Jill crazy whistling, but feel free to ask us about that in the question period.
I think with that, we can just, if you go to the next slide, you can just talk about the basic idea is that these things seem to be more argumenty, right? These seem to be in between adjuncts and complements. So we could also talk about, and so the idea would be that these potentially involve bidirectional selection. So these are adjuncts, but they're more directly integrated into the host than classic adjuncts. So what that means in the current model is that it's not just that the adjunct selects the host, but the host also selects the adjunct. And if you allow for bidirectional selection, then you essentially reconcile it with what happens with complements. And so you can actually explain these things. As potentially a way to talk about biphrases and passives, which have been independently shown to have more argumenty properties. This is recent work by Chris Collins. And also in certain languages, non-finite purpose adjunct clauses have been shown to be more argument-like. So these are the intuitions of this somehow more tightly integrated into the host. And we want to find a way to talk about that by saying that they are also selected in addition to selecting. I think that's it.
Yep.
So the first thing we do is unmute our microphones and clap, but with real noise, like actual sound. So please do that because that's our tradition. Then we're going to go to some questions. So thank you very much for the talk. You guys want to take your own questions? There's a lot going on in the box. We will have a transcript of the chats in the box saved for later. So if anything is too detailed or extensive there, we can post it together with the slides if you're willing to give us the slides.
Definitely.
And send it to you guys and you can write people more extensive answers. But right now I think we should go with not going to the box necessarily, but just people raise their actual hand or just speak up or raise their those hands used to be blue, but now they're various colors, right? So you guys want to take your own questions?
I think Asha,
Okay. Go ahead.
Prashka, yeah.
Hi, thanks for the very interesting talk. I have a couple of questions. One question has to do with the fact that it seems to me that what is ultimately responsible for which direction you can do agreement depends on, how you set up your checking system. I mean, this is exactly your claim, right? So my question now is, do we have meta theory of possible checking features that would actually make this system, explanatory? Because what you did with adjunct control is you posited this UCL, I don't know what that is, but this clearly did the work for you. So my question is, why couldn't we do that in the opposite direction for complementation and derive the opposite, interaction? So that's one question. And if I may go to the other question, it has to do with ordering of feature checking, in particular in cases where you have more than one feature to be checked, not so much on a single head. You could refer to, some ordering statements, order the probes or whatever, but more interestingly, in cases where you have checking from both sides, how you determine which one is checked first. That's also very critical for deriving the right facts. And what worries me most about that latter part is that you essentially by allowing selection from both sides, you allow for selection of constituents that have an unchecked selectional feature, which in principle allows you to have an adjunct adjoined to a VP or a verb that has not yet selected for its object, right? I think even categorical grammar has some mechanism in place to prevent that, precisely to allow adjunction only to fully satisfied elements, selectionally satisfied elements, to ensure adjunction outside of complementation. But with the system of checking from both sides, you have to abandon that requirement.
Yeah. Tom, can I answer the first question and then you
Sure.
or Hedda answer the second?
Yeah.
So with respect to the first question, that's a great question. So your question is, what is the sort of ontology of the sort of macro set of possible selectional features? Because if you can just add a selectional feature whenever you want, you can, that seems really ad hoc. So how can we make that explanatory? That's something that we've actually spent a lot of time talking about and worrying about. What our next step is going to be, one of the things that I'm pushing for is coming up with a very parsimonious set of checking features. So I would ideally like it to be the case that checking features are categorical features and nothing else, right? And that's probably not going to be enough, because as we know, you also need some notion of extended projection added, which is not only derivable in terms of sisterhood, checking under sisterhood. So this is something that David Adger talks about in his core syntax book, that you actually need a functional sequence of clauses in addition to talking about how things are selecting each other under sisterhood. So those are the two things that we need to do, is to come up with a parsimonious set of checking features that are really just about categories, so C, D, V, P, and so on, adjectives and so on, and only include those, and include a notion of extended projection for cases that cannot be derived only in terms of, for structure that cannot be built only in terms of checking under sisterhood. So those are the two things that we have to do in defense of the structure that we had with the UCL. That wasn't as entirely ad hoc as it might seem. We sort of didn't talk about that, but we're happy to say more about that if you'd like. But probably we can tell you more about that later. But
I also have an intuition that there's got to be something like this, in my own thoughts about control, yeah.
Yeah, exactly. So it wasn't just put there to make it work, though I completely understand your concern, and that's absolutely something that we should work on. With respect to the second question, that's really good as well, but I suspect that Hedda or Tom might have more to say about that. So.
Yeah, I mean, maybe exactly. So on the ordering, what order things have to go in, that's an open question. Hedda has, I think, wants to use that. Actually, has some arguments that in some of the cases, like you can actually do it either way, and that gives you different structures. And maybe Hedda, you want to say something more about that?
Yeah. So I think in principle, selectional orderings are free, but either semantically or phonologically or syntax internally, you can rule these things out without going into many details. Suppose a particular head would first select something that is traditionally the specifier as its complement, and then something that is traditionally the complement as its specifier would, for instance, ban all kinds of movements that would otherwise be necessary. So even if the syntax allows, in principle, selection in multiple orders, most of the unwanted orders are ruled out. And very briefly, that also, I think, in a different way applies to your completely legitimate concern that you don't want some particular verb to first select an adjunct before it selects its complement. Again, I think that even though syntax proper might allow it, it would give rise to semantic anomaly. If you argue that a particular predicate can only be modified by a particular adjunct at a semantic level, if all its arguments are saturated, then this would give that would give a structure that is syntactically fine, but would require the adjunct to be interpreted as an argument and the complement to be interpreted as an adjunct, which gives rise to a semantic anomaly. So that's how I think I would rule it out. But in these collaborations, we're all complete minimalist syntax, and the definition of a minimalist syntactician means you have a framework of your own. So maybe Tom or Sandhya have different ideas about how to do this.
Yeah, well, like we could put put that in the category of questions to be answered in the course of the project.
Yeah, I think we should go to the next question though.
Yeah, so I think maybe Rob Pasternak is next.
Sure. So I guess this might be just a very basic mechanical question. So it seems like the principles of constraining enrichment. You need to know what has selected what over the course of the derivation. But when the way that the features project, it seems like you lose that information over the course of the derivation, right? Because the selectional features don't sort of project upward. So I was wondering, is there some way that I'm missing as far as how that can be sort of surmised from the structure as it exists at the time of enrichment? Or does some sort of derivational bookkeeping need to happen? So yeah, that was just sort of a mechanical question.
I can say something about that, Sandhya, if you want. So there's two different things that you can say about that. One is first of all, it's important that in this system, checking has literally no effect, except that it's required for merge to take place. And the only real effect that it has is that it prevents things from being projected up. But nothing is done to the features that are involved in checking. They're still there. They're just only at the level where they were. So that means no information is lost. So it's there. You can always go back and follow that information as needed. So we can come up with a specific implementation that just sort of follows that information. It doesn't have to be reconstructed per se. It's there, but
one way to think about that is in terms of first order versus second order features. So we can say that first order features are C selection are features that are relevant for checking, and those follow the projection pathway that we talked about, but they don't apply to second order features. So even with the 5 features, you can think of it as an attribute value pair where the category is D, and then it has phi with various values as its values. And the categorical stuff follows a selectional pathway, but the second order features don't, right, Tom?
Yeah, that's right. And that comes to there's another idea that we've been toying with, but it's hard to work out. We're hoping to think about this more carefully. This deals with some of the other issues that I think I'm seeing in the chat with the valuation features. We'd like it to be the case that actually you could recast all of this in terms of constraints on the percolation of features. So the valuation features could also be involved in percolation as well. And if you get everything exactly right, what ends up happening is that also valuation only happens under sisterhood, but you get the percolation to come out as that sort of is what does the work of this setting up selection paths. We haven't figured out how to do that yet though. So but that's an idea that's there on the abstract level.
I mean, for now, we're sort of capitalizing on an intuitive distinction between features that are relevant for actual structure building and features that are not. And 5 features are not relevant for structure building in the same way as a D feature or another categorical feature. And that's the intuition we're capitalizing on. So somebody else, Tiazen? I'm mispronouncing the name.
Hello, everyone. Well, if I may ask, and if you allow me to ask, my question is related very much to the theories of semantics. So what do usually syntacticians put first? Do they put the features in order and then whatever structure you fill in these features applies there? Or do you get this all possible structures in the sentence and testify them there one by one? And what I mean by language is not only English, any other language. So do you like first fix the structure of the tree with the features there, the constituents, and then the words just come and fill up the places? Or do you like take the sentences and, keep playing with them until you come up with another, tree with a different constituents in different places from the previous ones?
Do you want to say something about that, Sandhya? Or
Uh,
okay,
uh,
so
So my question
So
is
I-
which one goes first?
right. So I mean, there's a bunch of different ways that you could think about that, and I don't think that our approach decides that. At least not what we talked about today. But I mean, so the way that one easy way to think about it is that you can, in principle, the system gives you a bunch of things that are possible. It constrains the way that you can put heads together to make a structure, and if at every stage you follow the rules correctly, then you will result with a structure. You will end up with a structure that's well formed, and then you can pronounce that. But you don't. It's not like it doesn't actually tell us how that procedure works. There are lots of different ways. So you could say that there's a procedure that says, okay, first of all, I'm going to start off with, I've got some idea of what I want to say, and then I'm going to figure out a way to say it. I'll try out all the different things until I get a way to say that matches what I want. Or you could say, no, instead I'm going to start off with a specific selection, a bag of words, and I'm going to play around until they fit together in the right way. But those are, I think the way that you go on that is independent of the stuff that we've said here. You could do it one way, you could do it another. I don't think we have a clear opinion on that.
Yeah.
Okay, thank you.
I think Elise maybe has a question.
Yes, thank you. I feel like you started to touch on answering my question, but I wasn't sure I understood it like more specifically. So I think the thing that I'm having the hardest time grappling with is the notion of adjuncts being able to project features, but not being selected for by things. So the fact that it's able to select for a verb phrase and then project its own V feature instead of that of the verb phrase sort of makes it look like the adjunct is being selected by any higher phrase rather than the matrix verb phrase itself. And so then you end up, I think, predicting the exact opposite of what you said, right?
Yeah, that's an excellent question. I'm going to let Tom answer that.
Yeah. Okay. So that is currently the fatal flaw in the way that we formalize the story. You're exactly right. If you go through the trees and you think it through carefully, if you do it mechanically, we make the exact opposite prediction for the opacity. Basically, it predicts that that adjuncts should be accessible, and the host that you adjoin to should become opaque. So the little VP,
in our
if you got a little VP.
In our defense, we don't predict that in general. It's just the one tree that you talked about.
Right. It's not so it's the specific implementation of the way that that adjunction works,
Yeah,
where the selection means that, so it's the thing, you've got a matching VUV on that characterizes the adjunct. That means, like you said, that the V feature that projects up after the adjunction comes from the adjunct and not from the host. And that means that when everything that happens upstairs should be able to look into the adjunct and not into the host. And we're working on a way to fix that. What's the more intuitionistic way to talk about it, which is that, you can, evaluation follows checking and selection paths gets it right. We just haven't figured out the right way to implement the features on adjuncts to get that to come out.
What you want is yeah, I mean, you want it to sort of forget where that feature came from at the point that it's projected, right? I mean, but at the same time, you want
exactly.
to have enough memory to know about selectional pathways for checking, and that's a challenge. But that's an excellent question, and it's one that we've been aware of, and we have some ideas about how to work it out, but they're not perfect. Thank you.
Cool, thank you.
I think John had a question. Yeah.
Thank you. I don't have a little hand electronic because I'm a co-host. They don't allow those.
Okay.
So thank you. I love this talk, and I'm very sympathetic actually to this way of doing structure building in general. And I sort of have two questions, but the first one I just don't want you to answer. I just want to ask it, which is similar to what other people were asking before. I mean, in the Azure system in core syntax, there's a couple of reasons why he doesn't use features up in the high functional domain as opposed to the sort of traditional C selection domain, right? One of them is the optionality of some of those categories. But for you guys, if I understand right, it's absolutely crucial that those are done the same way a verb selects its TP complement, the way a T selects little v, or selects, I use the word that would be good for you, rather than the way he does it, which is just stipulating a cartographic hierarchy, basically with optional elements in it. So that's a question that came up before. Can you really unite those two? I'm totally sympathetic to doing it, but I don't immediately see how it's going to be easy to do. And if you can't do it, then the whole system isn't gonna work. But that's the one I don't want you to answer. Okay.
But that's part of what Asha asked right at the beginning.
Yeah, exactly. It's
right.
exactly. It's part of that larger project. But I just wanted to express my sympathy for that project, and maybe we can talk about it more some other time. On the long distance Hindi agreement, though, what I didn't get is the role or lack of role of like blocking or minimality or something like that. So in the Hindi case, the successful final tree where you showed how it does work in your system, you had a high T and a very low DP, right? But there's a subject in between. So that didn't seem to interfere at all. It could go down and get the phi, have the phi be down low. And the fact that the subject in between has phi, it doesn't cause any, obviously, since it succeeds, doesn't cause any blocking effect. But of course, in control, we know that that's not possible, right? In control, there's probably something like a minimum distance principle. So I just don't see how, or have you, how does those kind of relative minimality things work in this system?
That's an excellent question. Yeah. Do you have?
No, so we didn't say it explicitly, but we are assuming minimality. It just what didn't do any work for us. Because the whole point about those Hindi, the only way that you can get that long distance in Hindi is when the subject is ergative. So the ergative subject is not a valid target for agreement, and so in a sense the agreement tries with the local subject first. That fails because it's oblique, and then only then can it see past into the embedded clause. So we are absolutely assuming that like evaluation follows the path, and you have to go with the first thing you hit.
Yeah, I assume that you would be assuming that somehow, just as long as there aren't cases that complicate
really good
that.
Question.
Yeah.
We are assuming minimality. A different question, related question, is whether we also need phasehood, or whether combining selection plus extended projections will somehow get us that. Because if it all works out, the way in which the order in which elements are merged in the structure will be such that by the time you reach what is traditionally called a CP, you will have done all the checking relations within it already as a function purely of the kinds of features that individual elements are born with. Plus the functional sequence, right? We'd have to say something about that. But we don't necessarily then need something that additionally says a CP is a phase, because a phase is essentially just something, is a chunk of structure within which all valuation and checking has already happened.
Right. No, it wasn't the phasal properties, it was just the relativist minimality.
Yeah.
Right. No, I see. Okay. So there may be some cases that need some working out, but I get the big picture. Thank you. Thank you so much. And not to end on my own question, but are there any one last question? And then we promise we will, if you guys are okay with it, we will post the slides. We will post the relevant, we'll clean up the stuff that's not relevant, we'll post the relevant parts of the
Can we also
discussion.
have a way to answer the questions in the chat that we didn't get to?
Sure. Absolutely. Let me think about that.
Really
we just have to.
Yeah.
Absolutely. I mean, you let me know we'll post the chat. You let me know which ones you want, and we'll get you the email addresses for the relevant.
I mean, we're
people.
happy to answer all of them. I mean.
Okay, then we can just post a document. We can post a document.
Exactly. We can do that. Yeah.
Okay.
I think.
Any last question?
I think David has a question.
David seems.
Well, I had my hand up, but if you would use the time to answer one or another of the questions in the chat, I would rather do that, and I can contact you later.
No, I think the chat. I think we're We're gonna, yeah, the chat will do separately in writing.
So I had
David, go ahead.
okay, so I had a sort of philosophical question. I mean, this is one of the descendants of Keynes' work on ECP extensions and connectedness, and then it's kind of another line of descent. And I'm wondering if you could compare your approach to that, which is, you know, kind of represented by a bunch of people, ideas that Uriah Gareka and Kyle Johnson and other people have had, which is, you know, suppose we were to take from your talk the notion that in obligatory control, there's a needy element, this pro, that has to look up the tree to satisfy its needs. And so this other line of descent in general is the one that would say that non-complements get frozen in some fashion once they're built, right? So if you put that in a merge framework, you know, you build things up, and if you're a complement, you remain transparent in principle, put phases aside. If you're a non-complement, you become opaque, right? So becoming opaque will, all things being equal, make you an island for probing, for agreement, and for movement. And if you were to modify that view in one way, namely you're opaque except for anybody within you that has a need, right? You would get a result similar to the one that you took as the foundation for your talk. So in the case of obligatory control phenomena, the adjunct is opaque, except there's this little voice crying out from inside the adjunct saying, control me, which can be heard past the adjunct. And that's sort of in the same line of descent, but it's philosophically different approach to the problems that you're taking. And I'm wondering if you've thought at all about, you know, what would favor your approach over the other, or whether there are two ways of looking at it that turn out to be the same in the end.
Just real quick, I'm not entirely sure. I mean, it seems to me that the version that you described is less economical than the one that we described, because you have to have an independent condition, a rule of this, any non-complement is opaque, which, where does that follow from? And then you're also additionally using the opacity, you're also additionally using the selectional need kind of thing as a way to avoid that conditionally. And it's not clear to me why that would be better than not having an ad hoc rule of non-complements being opaque and just trying to derive opacity, selectional opacity, purely using selectional pathways the way that we're doing, unless I'm misunderstanding.
So a number of people in that other line of descent have appealed to linearization, for example, as a reason why you need to spell out non-complements right away. You know, I'm not personally putting my full faith and credit in any of this. I'm just sort of interested in the issues. And then indeed, we'd be borrowing from you the notion that control is an upward relation as opposed to a downward relation, and sort of adding it to that philosophy as opposed to yours about handling the rest of the stuff.
My intuition, so I think I agree exactly with what Sandhya said, and like, to go a step further, it seems to me like if it were the case that adjuncts were just and subjects and other, you know, non-complements were just opaque, then that would actually be a really nice bit of evidence for the, you know, things become opaque approach, the multiple spell out and so forth. That would actually be really nice. It's the fact that they're only opaque in one direction that makes that a bit trickier to do. And I've always liked that idea that, okay, it has to become opaque because you need to spell it out. So you're turning it into a word, which is not an object with internal syntactic structure anymore. So you could, I mean, one like little tweak that you could try to do to save it for these specific cases would be to say, well, okay, the reason why control works, the reason why the dependency for control works is because pro is silent. So, and the control dependency has no effect on its pronunciation. So you can fix its pronunciation and spell it out, and then figure out its reference later, and everything works out okay. But agreement doesn't work like that. Agreement, you need to actually copy 5 features to do the pronunciation. But then, if you do that, then I don't know how you do like adjective concord, because adjective concord is an adjunct that needs to get its 5 features valued from outside, and that determines its pronunciation. So,
and don't forget that pro is not always silent. even obligatory control prose, not
True. Yeah.
Right,
Exactly. Exactly.
That's exactly what I
Okay.
was about to say. Yeah.
that
Yes. Exactly. Exactly.
doesn't
Okay.
entirely
Good.
work either, but yeah.
Yeah. I mean, yeah, I like,
That's
I've always
good.
liked that other
Yeah,
approach
yeah.
too, but yeah, but I think, yeah, that would be very interesting to see if there's a way to sort of do that.
Thank you. Very interesting talking. Thank you.
Thank you.
Thanks.
On that note, the people who are still with us, 37 people, please to open your microphone to real sound and let us thank you so much, you guys. It was great.
Thank you.
Thanks, Sandhya and Thomas, for their talk.
This.
And we will post various things related to this talk in the general lectures folder. So stay tuned for that. And bye, everybody. We can stop the recording and the streaming. And thank you all for coming.